All right, guys, we might go ahead and get started. Thanks for joining me. My name's Rowan Miller. I am a program manager on the Entity Framework team here at Microsoft. Been on the Entity Framework team for about 4 years now. It's the only place I've worked here at Microsoft. Been a program manager for the best part of 2.5 years now. You're here because you want to learn about writing data-centric applications, and in particular, we're talking about applications that can target multiple platforms, the obvious ones being desktop, the phone, and on the web as well. So we have a very simple agenda. I want to take a second to talk about the different ways that you can create a model using Entity Framework. We're then going to take a couple of slides to look through what's new in Entity Framework 5. That's our latest release. Then the bulk of our time today is going to be spent doing demos. So we're going to be writing code in Visual Studio. Once we're done with all that, we're going to take a look at Entity Framework 6, which will be our next release. We'll look at what features are coming in that, the time frame for when it's going to ship, and a few other nice pieces. And then if we have time, I'll do a quick demo of what I think is the coolest feature coming in that release. So let's talk about developer workflows for a second. You've probably heard of model first, code first, database first, the Entity Framework Designer, and it's a little bit confusing which one you should use in which scenarios. Which one is right actually boils down to two very simple questions. The first one is something that's completely outside of your control, and that is, are you targeting a new database or an existing database? A new database would be a database that hasn't even been created yet, or a database that is waiting for tables to be added to it. An existing database could be a database schema that your DBA has created and given you to work with. It could be the database from an existing application, something that's already out there in a brownfield scenario. The second question is something totally inside your control, and that boils down to whether you would prefer to model using boxes and lines in a designer, the kind of drag and drop style interface, or whether you'd rather model using pure code. So these two pivot points basically make up a grid with 4 different options for using Entity Framework. If you want to use boxes and lines and target a new database, then the workflow for you is model first. In model first, you draw your model with boxes and lines. Your database schema is then generated from the model, and the classes that you're going to interact with when you write code are also generated from that model. Our next box is database first. In this one, we still use the designer, but instead of starting from scratch, we get the designer to reverse engineer a model from a database. We can then tweak the shape of the model or the way it maps to the database. And again, the classes that we're going to interact with when we write code are also generated from the model. Moving over to the right-hand column, we get to code first. In the new database scenario for code first, we write our model by writing classes in code. We can then optionally write some extra code that gives more information to EF about how the model should map to the database, or what the database should look like. And then our database is generated from our classes, and obviously we interact directly with the classes we wrote. The final box, and one we haven't done a very good job of talking about so far, is code first to an existing database. When we labeled it code first, it obviously makes it sound like you write your code first, and then your database is generated for you. Some people call this last box code second, in which we have an existing database, we use some tooling to reverse engineer some code, and then we can tweak and edit that code as we see fit. You can, of course, write the code by hand if you want, but if you have a big database, you're probably going to want our power tools to help you reverse engineer it. So moving on to Entity Framework 5. This shipped a couple of months ago, and the primary release vehicle for it was on NuGet. So if you go to nuget.org, you'll see the Entity Framework NuGet package, with its current version sitting at 5.0.0. In addition to being on NuGet, Entity Framework 5 is also included in the box in Visual Studio 2012. It's included in a few different places. One example would be if you write a web API or an MVC application, then the Entity Framework package is automatically installed by default in that application. Now, we don't reach out to the web to install it. It's actually included on disk when you install VS 2012, and the project templates will pull the NuGet package from disk. So it looks like you installed it from online. But if you're working in an environment, such as some government organizations, that don't let you reach out to the web, then everything still works. One other place it's included, if you create a new model with the Entity Framework Designer in VS 2012, then we'll also automatically install the NuGet package for you. It's worth mentioning that in VS 2012 we did make a bunch of updates to the EF Designer, and we'll talk about some of those in a second. While it's included in VS 2012, EF5 also works with VS 2010, which obviously means it works with .NET 4 and .NET 4.5. If you target .NET 4, there are some features that you're not going to get. We'll talk about those on the next slide. This is because in EF5, some of the core components of Entity Framework are still inside the .NET framework. Although we have a lot of our stack shipping on NuGet, some of it's still in the framework, so to do those features that required updates to those components meant that we had to rev the framework version. Now, one of the cool things we'll talk about at the end is in EF6, we're taking all those components that are left and moving them into our NuGet package, which means we won't be waiting for .NET releases to roll big features anymore. In fact, even cooler, all the features that currently require .NET 4.5 in EF6 will actually work on .NET 4. So what's in here? There's a few features that apply to the EF Designer and to Code First. So regardless of the approach you take, you'll get support for enums, which is something people have been asking for a very long time. You'll get access to spatial data types. These are akin to spatial data in, say, SQL Server, where you can work with geography and geometry data. You'll also get some big performance improvements. We run an end-to-end application here that's designed to be somewhat analogous to a real-world application, and we saw a 67% performance improvement just by upgrading to EF5. Obviously, your mileage will differ depending on what your application actually does, but in a fairly database-intensive, Entity Framework-based application, we saw a 67% improvement. There are also some features that are only available in the Designer. You can now map to table value functions in your database. This will come in Code First later on, and we'll talk about that when we get to the EF6 slide. You get multiple diagrams and coloring. So if you have a big model, there's now a way to break it up into separate diagrams and to use coloring to differentiate pieces of the model. Now, DB Context has been around for a while. This is our simplified API surface that is a facade over the top of the more complicated and very large object context. In previous versions, you could actually use DB Context with the EF Designer, but you had to install some templates off VS Gallery. With Entity Framework 5 and the new Designer in VS 2012, we actually generate DB Context code by default. So enough going through slides. Let's see some of these in action. We're going to build an application called Park Finder. And in this, users are going to be able to enter the location that they're at. In our case, we might type in Seattle. And we're then going to load up a map and a list of the nearby parks with them called out on the map. Let's take a look at the architecture before we start diving into code. So the left-hand side of the slide represents what our application is going to be. So it's going to start with some search text that your user is going to input. It's then going to reach out to the Bing Maps API, and it's going to take that text and turn it into a set of GPS coordinates. Once those coordinates come back, we're going to build a web service or a web API that will take those coordinates and return all parks that are in close proximity to the coordinates. Once we've got that and the results come back, we're going to bind them to a Bing map and a grid view on our design surface. When we build the web API, we're going to use Entity Framework to talk with a local DB database. Local DB is kind of the in-the-box database that comes with VS 2012, kind of akin to SQL Express in VS 2010. So we looked at this diagram a minute ago, and we're going to be targeting to start with this scenario here, where we're going to write some classes using Code First, and then we're going to let those classes create the database for us. So what I've got here is a fresh instance of VS 2012, and we're going to go ahead and start working on the web API component. So we're going to create an MVC4 application. Call this one parkfinder.web. And we'll select the web API template. So I'm not going to focus too much on web API today, but Dan Roth from the web API team is going to have a great talk on it tomorrow. So you'll see a bit of it. If you want to know more about web API, then I'll have a slide at the end that points you in the direction of his session tomorrow. So the first thing we want to do is create the model that's going to represent the data we're going to work with. So over in Solution Explorer, I'm just going to add a class to the models folder. Call it model. And I'm not going to make you watch me type out a set of classes. I've got some code snippets you'll see me use. So nothing new here. This has been around. If you've seen Code First before, you'll know that it's a very simple POCO model. All I've done is write properties with getters and setters. And the navigation properties are represented as lists and just reference properties between the classes. One thing you will notice is we have a DB geography as a type on the location property. I'm just going to resolve the namespace on that, system.data.spatial. This is a new type in .NET 4.5 that represents geographic and geometric data. So I'm just going to build the application, and let's go ahead and scaffold an API controller. We'll call this one the Parks controller. We say we want to scaffold it to expose instances and be able to save instances of our park type. And this data context is, in EF speak, this is going to be a DB context. And this thing is going to represent the session with our database. It's going to allow us to query for data and to save data back to the database. We haven't written one yet, and one nice piece of integration with Web API is I can just select new data context. We'll call it the Park Finder context. And Web API will take care of creating one for me. So now the scaffolding's spinning away. It's looking at the shape of my park class, generating some code for the API controller, and also generating the DB context to interact with the database. You can see it's added the context to my models folder. And looking inside it, we see it's very simple. It just exposes a DB set of park. And this is a property that's going to expose instances for query and allow us to add instances for save. I'm not going to dwell on the code in the parks controller, but suffice to say it's going to generate a code to get all parks, to get a park with a given ID, and to insert, update, and delete instances of park as well. So let's fire up our application and see what happens. So I'll just wait for it to spin up. I'm going to use Fiddler here. For folks who aren't familiar with Fiddler, it's just a way of issuing HTTP requests and then viewing the contents of the requests as they come back, or the contents of the response, rather. So I'm going to go ahead and hit, within our website, API/parks. We'll see this first request is actually going to take quite a while to execute. One of the reasons it takes a while is because we're letting Code First create the database. So in addition to a whole bunch of Web API stuff spinning up, Entity Framework's taking a bit of time to work out what our model looks like and create the database to match that. Let's go ahead and look at what it returned. If we look at the text view of this, we'll see at the moment it's just returning empty JSON. And that makes sense because we haven't put any data in our database yet. So coming back to Visual Studio, we're going to enable something called Code First Migrations. Now, Code First Migrations allows us to make changes to our model and then to push those changes to the database. And we'll look at actually doing that in a little bit. But first up, I'm just going to type the enable migrations command. Zoom in a bit for you there. Okay, so what it's telling us, it's enabling migrations. It saw that we already have an existing database that it's applied some changes to. So it's taken care of that and scaffolded a migration to represent the changes that are already in the database. That's what that big string of bright yellow text is telling us. So if we look at the migrations folder, which I'll just zoom in on for you, we'll see two classes in there. One is the configuration class, and this allows us to configure a bunch of settings for how migrations works. And the other one is that initial migration that records the changes we've already applied to the database. And as part of enabling migrations, Code First has already recorded in the database that this migration has been applied. If we look at that migration, we'll see some Fluent-ish style API here that's describing the parks in the events table that it created. The other thing we get inside configuration is this seed method. And seed passes in an instance of our context. We'll just scroll right a bit. and allows us to insert some data into the database. So we're going to make use of that. So we're going to drill into the parks property. And we're going to use this add or update method, which is actually an extension method in migrations. What this allows us to do is pass in a bunch of parks, and if those parks are already present in the database, it will update them with the values supplied. And if the park doesn't exist, it's going to insert a new park. Now, by default, it's going to match based on primary key. But that doesn't make much sense for us because the primary key is generated by the database. So I'm actually going to tell it to match on name instead. Once we've done that, we want to drop a bunch of parks in here. So here's some I prepared earlier. Oh, that's not going to work. All right. You really didn't want to watch me type that out. So you can see here I'm creating parks. I'm giving them a name, which is what we'll get matched on, a location. So I kind of want to call something out here. When we're working with this DB geography type, it's not that great at the moment. We tried to get a much better object model into .NET 4.5, but we just didn't have time. So in the next versions of EF, you're going to see this object model get a lot better, and you won't have to do things like using from text to create instances. So let's go ahead and run the other migrations command, which is update database. Update database will look if there's any pending migrations, which there aren't because we haven't added any apart from the initial create one. And it's also going to go ahead and apply our seed data. Once it's complete, let's just go ahead and reissue this request. And this time, we get a bunch of JSON back for all the parks that we created, 7 in total. You'll notice here that there's some from Seattle and also some from New York. So this gets us part of the way to our application, but remember we actually want to be able to pass in some GPS coordinates and get back the parks that are close to that area. So to do that, we're going to add a second method to our API controller. Just give us a bit more room back here. So here's a signature for a method that's going to take a latitude and a longitude. It's going to use them to construct a new instance of DB geography. And then we're going to write a link query that's going to find the parks close to that location. So this is the DB geography instance. And we get a nice strongly typed API over it, so I can find the distance from the location we just constructed. We want to get parks back. And then I'm just going to return these by calling toList. Now, one thing I missed here, we want to restrict this to a certain minimum distance. So I'm going to pick 10,000. Now, this API is actually in meters. So it's going to return 10,000 meters, which is 10 kilometers. So we want all parks within 10 kilometers of the given coordinates. Let's just go ahead and build. And I'm going to take this string here. You can see I'm just, as URL parameters, passing the latitude and longitude. Web API will take care of matching that up with the method. And when that returns, we'll look at the JSON and see that this time there's only 4 parks in there, and they're all around Seattle. All right, so far all we've done is we created a code first model, scaffolded an API controller on top of it. We hit the API controller and let code first create the database. We then added a method to our API controller that would allow us to find parks based on a where clause that restricted them to be within 10 kilometers of a DB geography instance. Now let's write a proper application, because we can't expect end users to use Fiddler. So of course we're going to build a Windows Store application for Windows 8. I call this one parkfinder.desktop. And the first thing I'm going to do is add in a few references for us. So I have the Bing Maps SDK installed. You can get this off VS Gallery. So I'm going to include Bing Maps, which in turn requires me to include the C++ runtime. both of those components, if I just zoom in, you'll see they have an exclamation point next to them. That's because to use these, I need to pick an architecture to target. So at the moment, my project is targeting any CPU. I'm just, for this demo, going to use x86. The other reference we're going to need is a reference to the Bing Maps API. This is going to let us take the text that the user enters, such as Seattle, and turn it into GPS coordinates. It's a very simple API. If I look at it, it just has a geocode and reverse geocode method. And then the final reference we're going to need, when the data comes back from Web API, it's in JSON format. And we're going to want to turn that into a bunch of classes. And one of the best components I've seen for doing that is to use JSON.NET. So I'm going to add that NuGet package as well. All right, so we've got our references in. Let's go ahead and load up the main page and implement that. Again, I'm not going to make you watch me type out a whole bunch of XAML, and this isn't really UI talk, so just paste in a bunch of code. I'll walk you through it quickly. At the top, we basically have just a text box telling users where we're at. Next in, we have the text box that allows them to enter the location they're at and a search button. And then below that, stacked side by side, we have a Bing map and a grid view that's going to visually display the data. So let's go into the code. So remember, we're going to get JSON back from the web service, but we want to work with objects. So I have a slightly stripped down version of the model here that we're going to use. We're just dealing with parks, so I've left events out of the client model. One thing you will notice, I mentioned DB geography isn't such a great type, and that really shows up here where I have to create this kind of strange class structure that maps somewhat to the DB geography type. One thing you'll notice, really the only property that we get back that's any use is the well-known text property. So when JSON.NET comes to set this property, I've included some logic that will basically parse the string and turn it into a latitude and longitude for us. Again, this is pretty horrible, and it's something we're definitely going to look at in the next version of EF. So now that we have our model, we can write some code that will hit the web API and populate the model for us. So I'll just walk you through this one quickly. This is after we've got the GPS coordinates. We're going to load up the Bing map centered on that location. We're then going to use HTTP client to go and hit our web API. And I need to put in the URL of our server here, which is the local one. We then construct the URL based on the latitude and longitude. This looks very similar to the URL we created in Fiddler. And then we wait for the response to come back. When the response comes back, we use JSON.NET to deserialize into our object model. We bind that object model to the grid view, and then for each park, we go ahead and drop a push pin on the map. So now all we need is a method that will be able to turn the user's search text into a set of GPS coordinates. So I've got one here called geocode. I'll just resolve a couple of references. So I don't want to go into too much detail on this one, but we're basically calling the Bing API web service. You can see I need to pass in my Bing Maps key, so I won't scroll right and show you that. And we basically strip out the best match. So the one that Bing Maps returns us as the top result, we're just going to assume that's the right one and go ahead and pull out the coordinates for it. So the last thing to do is to wire all that up to our search box. So when the user clicks search, we go ahead and find the location based on the text that they've entered, and then we go ahead and load the parks for that location. Now I'm a PM, so I probably should be getting a code review, but fingers crossed this works. Cool. So let's do Seattle. We know there's some parks around Seattle. Hit search. We'll see the map load, and then a fraction of a second later when our API returns, we'll see all the parks load onto the map. So what I want you guys to take away from this one isn't just about EF, but how all these pieces are starting to plug together pretty easily. This isn't a demo that I spent weeks getting together. This is something that I sat down one afternoon a couple of weeks ago and tried to write this app, and it's actually pretty easy these days. So we've built an application, maybe we've published it out already, and we decide that we need to capture some more data. For example, we might want to have a rating property on parks so that our users can tell us the parks they like and the parks they don't like. So I'm going to go back to our web project, and we're going to do just that. We're just going to add a rating property to parks. Now, we'll use migrations in a second, but let's just fire this up and see what happens. So I'm attaching the debugger to it so that we get notified if there's an exception. Once it's loaded, I'll go ahead and run our Park Finder app again. You'll see the map centers, and then it seems to freeze for a second, and then we get an exception in our web app. And I'll just zoom in for you. And it's basically telling us that CodeFirst has detected that the model and the database are now out of sync. And nicely, it tells us that we might want to consider CodeFirst migrations and gives us a URL to go off to. Fortunately, I already know how to use it, so let's stop this. And back in Package Manager console, I'm going to call add migration. And what this is going to do, CodeFirst is going to look at my model, what it looks like now. It's going to look at what the model looked like last time a migration was scaffolded. Remember, that's the initial crate one. And it's going to look for changes and then generate a script to update the database. I get to give these a name. This is just free text. It doesn't matter what I call it. And it will churn away for a second, look for changes, and it's gone ahead and added a rating migration into my migrations folder. You'll notice that the start of these files includes a timestamp. This just helps with ordering so that we know that the oldest migrations are at the top, newer migrations are at the bottom. Again, I guess I just want to call out, this isn't anything new. People have been doing code-based migrations for a long time. The one place that we add a bit of value, we actually scaffold the contents for you, so you don't have to make a change to your model and then hand code what happens in the migration. We take our best guess at scaffolding it for you. In this case, it's saying we're going to add a rating column to parks that's of type integer and non-nullable. The other thing I'm going to do is just add some seed data so we can see it get added. So I'm going to give one of our parks a rating of 5, and the other one a rating of 3. Now, because these parks already exist in the database, migrations is going to match the name, so Volunteer Park Seattle and Gasworks Park Seattle, and just update the rating properties for us. So using Package Manager console, which I'll zoom into, I'm going to run the update database command again. This time we see that it found one pending migration, which is the one we just created. So it goes ahead and applies that to the database, and then it runs our seed method again, which is going to update the ratings. Now, one thing I love about Web API and JSON.NET is that it doesn't matter if stuff changes. If we do additive changes, it's all just going to work. So Web API is just going to seamlessly return this rating property in its JSON. And then JSON.NET is going to deserialize it, and if there's no rating property, it doesn't care. And obviously our API doesn't use the rating property, so that doesn't matter either. So we can do additive changes to our model and our database, and Web API, JSON.NET, all our client technologies keep working. But let's say that we actually want to update our web app to use this. So let's go back to the desktop. I'm going to go down to our client model at the bottom. This was the first thing we added. I'm going to add in a rating property. And then on the main page, I'm going to take out this line that just displayed the name, and I'm going to copy-paste in some code that is going to display the name and then the number of stars in brackets afterwards. Let's just run again. Punch in Seattle. See the Web API is still spinning away in the background. It eventually comes up, and we can see now that some of our parks have the stars displayed. So again, I think with code-first migrations, we get a lot of control over what happens in the database. And in a second, we'll look at times when you need a bit more control rather than just doing what code-first does by default. And then all the technologies on top just kind of seamlessly expose the data, and we can take advantage of it when we need to. So let's look at something that requires a few more changes with migrations. I'm going to go back to our model class. And I can't help, people have been asking for enums for so long that I just have to throw it in the demo. So we're going to add an enum property to park. And we'll call it park type as well. So we know that if we go ahead and add migration, it will go ahead and scaffold its best guess at the changes, which in this case, my enum's an integer, which I want to call out as the only types of enums that EF supports at the moment, although we are working to support different enums, not just integer-based ones. So it's scaffolded an integer column for us, but what if we want to do more? What if we want something like an index? Now, the cool thing is, because migrations is a little bit divorced from your code first model, you can do things in here that aren't natively represented in the code first model, such as adding an index. So we actually have an API for this one. So I'll copy down some code. So we create an index on the park type property, or the park type column in the parks table. But like I said, this thing's divorced, so we can actually do some other stuff that's not represented in code first. So one of the complaints people have had is code first picks a name for primary key constraints, for indexes, for foreign key constraints, and you don't really have the opportunity to customize that. But now in migrations we do. So I can say, well, the name for this one is ix_type. Maybe that's how my DBA likes things to be done. So then in the down, obviously, we want to do the reverse. So we want to drop the index. I want to drop it from the parks table. And we have two options here. We can either tell migrations which columns the index is on, and it will find it and drop it for us, or we can just tell it the name. So because we gave it a name, let's just use that. And we should really drop it before we drop the column. And then we can go ahead and apply this to the database. Let's just add a connection to our local DB instance. I know we haven't really looked at the database so far, but let's just see where it's at the moment. So Web API picks or appends a timestamp to the end of databases. Now, you can totally change database names. You have a lot of control over what the schema looks like as well. But this is kind of what happens by default. If we look in there, we'll see the tables that Code First has created and the parks table with a whole bunch of columns on there. Just some conventions are working out what to do. And if we look under the indexes, we'll see that our new index is in there, ix_type. So that's great for things that we have a native API for, which really, apart from everything you can do in Code First, is just indexes. What about stuff where we don't have an API? Say, store procedures, for example. Let's go ahead and add another migration. We'll call this one Sprock. Remember, Code First is going to look for changes in our model since we last generated a migration, and there aren't any, because the last thing we did was add the enum type. So it's just going to give me an empty migration so that I can do whatever I want in here. So I'm just going to bring in a code snippet to create a procedure. So I can use the SQL method to execute any random SQL against the database that I want. We should get rid of the store procedure in the down method too. So I'll just copy some code down. Say instead we want to drop it. And then let's go run update database again. So now if we look over in our database, we will see a get parks by rating store procedure. No surprises there. So one interesting thing is Code First doesn't support store procedures. And you'll see at the end, we're actually going to add support in EF6. But while EF5 is all we've got, we can still use store procedures for doing select data or for selecting data from the database. So I'm going to go back to the parks controller. And we're going to add in another method, get parks by rating. And this allows the caller to pass in a minimum rating for parks. Now we're going to make use of a cool feature on the DB set called SQL query. And what SQL query allows us to do is punch in any random SQL that we know is going to return instances of the type park. So I'm just going to go back to my migration and copy the name we gave it. So you notice what I'm doing here is using a string.format like syntax to pass in the parameters to the SQL query. Now I call it string.format like because obviously we're not doing string.format. That would open us up to a lot of SQL injection attacks. So EF is going to take care of creating a SQL parameter and then punching it in the right place for where I put little squiggly zeros. We need to return that. One thing to call out, SQL query doesn't use any of the mapping you create. So if you have a column in the database that's called park_name, and you have a property on your class that's called park, you're going to have to alias that column in the SQL that you create. We've actually had a bit of feedback for folks asking if we could support mapping directly from SQL. So we're looking at an overload for this method that would allow you to tell us that you want us to use the mapping you defined. Let's just build the app. And I'm just going to copy the URL. We'll see this time it's just returning 2 parks, and these are the ones that we added the rating to, a rating of 3 and a rating of 5. So a couple of other things I just want to show you while we're looking at migrations. So say you make a mistake in a migration, or you want to roll back to what the database looked like at any given point. We can call update database, and we can pass in a target migration. And in our case, let's go back to park type. And what this is going to do is roll our database back to what it looked like at the end of the park type migration being applied. So migrations is going to tell us what it's doing. It basically discovered that to get back to park type, it has to revert the one pending migration, or the one migration called Sprock. So it's gone ahead and reverted that using the down method that we supplied. A lot of people, when they see migrations, the first question is, well, that's great, there's no way my DBA is going to let me run that against the database. So fortunately, we thought of the DBAs. So we have a dash script, which is going to give us a SQL script. And we can say the source migration is, you can pick any migration name, but we can also specify initial database, which will give us right from the start. We can also specify a target migration, but if we don't, migrations is going to assume that we want it right up to the latest state. So I'll go ahead and run this. And we get some pretty SQL that we can hand off to the DBA. One thing our teams spend a lot of time doing, custom-generated SQL often looks super ugly, and it has lots of comments and weird set ANSI level blah, blah, blah in it. We tried to keep things really simple. So you can derive from our SQL generators if you want to customize the way the SQL looks too. But by default, we try and generate a SQL script that's simple and will run on as many databases as possible. We do also have a provider model in migrations. So if you want to run against SQLite, etc., you can plug those in and use them as well. So in this demo, we just looked at the top right corner, which was code first to a new database. I just want to take a couple of minutes to walk through the complete opposite corner. So what does it look like if we're using, say, the EF designer, because we like boxes and lines more than code, to map to an existing database? So to do that, I'm going to make use of the application that we've already created. And I'm basically just going to strip out everything that's code first related. So I'm going to delete the migrations folder, delete the model in our context, and then in web.config, I'm going to delete the connection string that Web API added. And then if I look over here in Server Explorer, you'll notice on my local DB instance, I have a park finder database that I already created that has the events in the parks we just looked at, but it also has a couple of extra tables as well. These extra tables relate to employees and the parks that they're going to work at. So I'm going to right-click on the models folder and add a new item. We're actually going to add an entity data model. It's probably not particularly well named. When you add this, you're really adding an entity framework model. So we're going to generate it from an existing database. This horrible string connects us to local DB. We're going to select the Park Finder database. I'm going to rename the connection string in the config file, not because I really care what the connection string's called, but the name of the connection string actually also gets used for the DB context class that will be generated. I'm going to select all the tables and all the store procedures. You'll notice we have the same store procedure that we created using migrations is also in this database. All right, let's get a bit more real estate. So you can see parks and events are there, and then we've got these kind of employee-related 3 tables up the top. Before we do anything, I'm just going to build the application. And I'm just going to reissue our first request that got all the parks. And all I want to show you here is that it doesn't matter how you create your model, whether you use code first or whether you use the EF designer. The code that you write once you've done that is exactly the same. So it's the same API surface. The decision you make on that grid, whether you go designer-centric or code-centric, only affects how you create your model. While we're here, let's just take a quick look at the code that's getting generated. You'll notice there's a context and an entities, or set of entities that get generated. So the context is very simple. I don't know if anyone's looked at the code we generated back in earlier versions of EF based on object context, but you would have hundreds of lines of code, and it would be impossible to work out what the heck's going on. Even hard for us to debug in our team. Now with this much simpler API surface, it gets a lot easier. In turn, the entities themselves are also very simple. Back in the earlier days, you would have seen a whole bunch of attributes on here, a whole bunch of interfaces implemented. Now these are just the same kind of classes you would write if you were doing code first. So let's look at some new features in the designer. My model really has 2 different parts to it, the parks and events and the employee stuff. So one way to break it up, if I just load up properties, is to apply coloring. So I can look at my model and see that there's a purple bit and a blue bit, and I assume they're 2 kind of logical subsections of the model. That might work okay for smaller models, but for bigger models, I probably want to split it up properly into multiple diagrams. So let's take those 3 tables. We right-click and move to a new diagram. So now, I now have 2 diagrams in my model, one that has park and event, and one that has employee assignment, and job description on it. Interestingly, it probably makes sense for the park to be included in this one too. So in the model browser, I can drag out the park entity type and have it included in both models. So park type at the moment in the database is just an integer column. And remember, in code first, we made it an enum. In the designer, we just right-click on the type and say convert to enum. Call this park type, and it has state and national. Now this is going to generate an enum for us, but if you have an existing enum that you want to use, you can tick the reference external type box and tell us which enum you want to use instead. So one final thing, with a designer, in previous versions, it was really hard to work with store procedures. You could tick the box when you created a new model, but then you had to manually go through and for every store procedure and choose to expose it in your model. So fortunately, in VS 2012, the designer does that for you. So if we look at function imports, which is a strange name for store procedures, we can see that it's already built a function import for us. But at the moment, it's returning it into this new complex type that it's creating. We actually don't want that because we know our store procedure returns entities. So we can tell it to return the park entity. Then the code in our controller starts to look a bit nicer, if I go back there. Because instead of executing a SQL query, I get a nice strongly typed method that I can call instead. Now, like I said, this is something we're working out how to do with code first. Obviously, it's a little bit harder, but we are working out a way that you can define a method on DB context and then map that method to a store procedure. I was going to show you one more thing. I won't go back to slides just yet. So far we've only targeted a desktop application, but obviously we write for more than just the desktop. Now we saw C# and XAML. Obviously that's going to work on the phone as well. We have that same programming model available. But I thought, just as a bit of a comparison, let's write a JavaScript web page that's going to access the API controller too. So our web API project has an index view that it displays when the application launches. So I'm just going to go over there, take out all the code that was already in there. Here's some I prepared earlier. What you're going to notice as we walk through this, I won't spend too much time because it's very similar to the code we wrote in the last application. But as far as UI goes, we have a text box and a button where the user can enter what they want to search for. And then we just have a map that we're going to display the results on. When the user clicks search, we kick off this function, which is basically going to issue a request to the Bing Maps REST API this time. So there's a whole bunch of string concatenation going on there, but basically it's passing in the text that the user entered. One of the things we tell it is what function to call when it comes back. So we're telling it to call location obtained. When location obtained comes back, we pull out, again, the best match out of the response, and we create a new Bing map and center it on that location. We then call load parks, which is going to hit our web API. And then when each park comes back, we're going to add a pin to the Bing map. So we'll just go ahead and run this. That's interesting. So let's search for Seattle again. We'll see Seattle pop up, and then the maps with pins on it telling us of all the parks that are around. Of course, we can also search for New York because we put some parks there, so we see the parks in New York as well. All right, so to kind of recap that demo, we saw how to build a data tier using EF. We used both Code First and the EF Designer and saw that the coding model, once we've created the model, is the same regardless of which approach we take. We then created two applications on top of it. One was a XAML C# Windows Store application. The other one just a simple JavaScript web page. So let's talk about EF6. EF6 we're actually developing in an open source code base. More than that, we're accepting contributions to the code base as well. The code base has an Apache 2 license and is hosted in a Git repository on Codeplex. So if you want to work out how some of EF works, go grab the code. If you want to help us fix some bugs, we'd love you to. One really important thing is that although we're operating open source under an Apache 2 license, when it comes time to ship, we're not making any changes. So it's still going to be a fully Microsoft branded and supported product. Still going to have exactly the same license, exactly the same support agreement, and more importantly, exactly the same quality, which means if you do want to submit bug fixes for us, you're going to have to write unit tests and the same quality code that people on our team write today. So far, we've been open source for a few months now. We've taken 4 contributions, most of them still quite small at this stage, but we've got a few bigger ones brewing in the community too. For EF6, we're targeting around about a middle of next year release. We're still working through when we can land all the right features to call it a release. I should blog at the end, but head to our team blog tomorrow and you'll get access to EF6 Alpha 1. Let's talk about features that are going to be in it. This is just some. Like I mentioned, we've got developers who have their own hobby features as well, but we also have folks out in the community who are looking at contributing some pretty significant features. So this is our list that we're working on at Microsoft at the moment. .NET 4.5 introduced task-based asynchronous, the kind of await keyword. So EF6 will support query and save async methods. We're supporting a dependency injection pattern. very similar to the pattern that is supported in ASP.NET today. This is my favorite feature. Had a couple of guys have been iterating on this for quite a while now. Code first custom conventions, which allows you, if you don't follow the conventions that we expect in code first, maybe you call your primary keys something different, or you want strings to default to a different length in the database, then you can write your own custom conventions. As I mentioned earlier, enums, spatial, and the performance improvements that previously required .NET 4.5 will now be available on .NET 4. Everything I've covered so far will be in the first alpha, so you can get those features and try them out. Another one that isn't listed on there, it's kind of part of the dependency injection pattern, is the ability to perform all configuration from code. So instead of having to use the web.config file, although you can still use the web.config file, all those same settings can now be done from code as well. We want to improve EF working against SQL Azure. So one of the key things we're doing there is connection resiliency. So you know with SQL Azure it's common to have a retry pattern. So you try a request. If it fails to start or fails partway through, you try it again. And that code is pretty horrible to write with EF today. So we're introducing connection resiliency pattern. EF tooling is a bit of a mess today. We have the EF Designer in Visual Studio. We have the EF Power Tools. They ship on VS Gallery. And we also have a bunch of code generation templates that also ship on VS Gallery too. So we're going to lump all of that into one MSI. And it's not just about getting it into one MSI. It's about having one entry point for EF2. So when it comes time to create a model and you do right-click, add new ADO.NET entity data model, you're going to get asked, hey, do you want this to be a code-first model or an EF Designer model? Do you want to target a new database or an existing database? So kind of pulling it all in so it's much clearer what's what. And as I mentioned, folks have been asking for this for ages. Store procedure support for code first. It bubbled its way to the top of our backlog, and it's going to be in EF6. So I've got a few minutes. I'm going to show you custom code first conventions quickly. So here's a simple little application that just has blog and post. You'll notice my primary keys, instead of following the code first convention of blog ID and post ID, in my organization we write blog underscore ID and post underscore ID. At the moment I have EF5 installed, so if I go ahead and run this app, I'm going to get an exception. It's basically telling me the model's invalid and that it can't find a key for blog or the post entity. So let's upgrade to EF6. So I'm going to connect to a local feed because Alpha 1's not public until tomorrow morning. And we're going to install a package, framework, and if I pass in the pre-flag, it'll give me access to pre-release versions. So we'll see it's going to install EF6, uninstall EF5. And then I'm going to override the onModel creating method in my context. This is where you traditionally do Fluent API configuration. So if I was using EF5 today, I'd have to configure two different things here. I'd have to say modelbuilder.entityofblog.hasKey blog underscore ID, and then I'd have to do the same thing for post. You can think if I have like 20, 30, 50 entities, this is going to get very lengthy. Fortunately, what I can do now is write some code that looks like this. So this is saying, to the conventions, add a new convention. And I'm going to take all my entities, I'm going to get the properties on those entities, filter them to any that end or that are made up by the type of the name and end in underscore ID, and then configure them as the key. I'll show you another cool one too. I like this one. Say your DBA says that all your tables need to be underscore or prefixed with T underscore. We can now write a convention that's going to take all the entities, configure, just call toTable like you would in the Fluent API, but instead of this being a strongly typed API, it's weakly typed. I can pass around strings, and I can give a new table name to every entity. So let's just go ahead and run this application. Go back to LocalDB and refresh. We'll see the new database it created. And I see all my tables there with the T underscore prefix, with the type name underscore ID properties configured as the primary key. So a couple of things to call out on this. This code I've written here is called lightweight code first custom conventions. We're still working on the naming, but at the moment it's lightweight. These are kind of building over some lower level building blocks. So these will let you to do the kind of things you can do with a Fluent API. Underneath these is a set of types that if you want to, you can derive from and write your own custom lower level conventions. Our guidance is going to be to stick to these where possible because they're a lot easier to understand, but you have the more complicated but more powerful API there if you need it. In terms of precedence, at the moment, the precedence for configuration goes anything configured using the Fluent API always outright wins. After that comes data annotations that you put on your classes. And then under that becomes our default conventions in code first. These new conventions that you write yourself sit in between data annotations and custom conventions. So any configuration you do outright, be it Fluent API or data annotations, wins. Any custom conventions you write come after that, and then anything we would do by default comes after that. All right, as we wrap up, some related sessions you might be interested in. If you want to know more about Web API, the details, the ins and outs of Web API, go and check out the top talk there. We've also got a couple of other interesting ones. Data options in Windows Azure, give you some idea of the types of things you can do with data there. And then if you want to go see a fun presentation, Bleeding Edge ASP.NET should be a good watch as well. Here's a bunch of resources you can head to. Our main website is the one at the top. On there you will find a whole bunch of walkthroughs, tutorials, information about EF. We're trying to push everyone to that site by default. Our team blog is the next one. When you want to get access to EF6 Alpha 1, hit that URL tomorrow and you'll find us there. Our Coplex site, obviously where we're doing open source development. If you're not interested in contributing code, still head there. You can look at feature specs, give us feedback on the designs we're coming up with. We're on Twitter. We're also on Facebook as EF Magic Unicorns. If anyone doesn't know the story there, Scott Hanselman dubbed us Magic Unicorn Edition back in 4.1. We loved it, so it stuck. If you need help on Twitter, use the #EFHelp tag. And if you want to visit my website, I have a blog, rowmiller.com. Please submit an eval for this session and the other ones that you attend. It helps us do better as speakers and to know what content you guys want to see in upcoming conferences. If you're interested in Windows Azure, follow them on Twitter and head to the URL I've got on stage there. If you do get Magic Unicorns and you want an EF sticker, I've got a bunch of them up the front here that you're welcome to come and grab. With that, I thank you very much for your time. I'll be hanging around if you have questions. Thank you.